I'm Karl Haworth, Product Technical Lead and Principal Engineer over our Developer Experience products. We're here to talk about how American Airlines drives developer experience and how Kuma Service Mesh is helping push our new shared hosting services. Fasten your seatbelts and prepare for takeoff. Last year, we started the developer experience product at American Airlines. As we transitioned into the later half of 2020 and into 2021, we wanted to tackle Kubernetes app deployments. Kubernetes is hard and cloud is hard. We aim to compartmentalize and make it easy for the users to always do the right things, no matter how difficult those tasks were, in a matter of minutes. Through our Kubernetes journey, we created reproducible patterns for application teams to use to make things even easier. Being a large company, we have a lot of opinions. Our blueprints help reduce the differences between application stacks. Now the throttle is maxed out and we're jetting down the runway. Talking about jetting down the runway, that's what we've chosen to call our product, Runway. We built our developer experience platform, Runway, on Spotify's Backstage platform. Backstage brings a solid base for an enterprise framework that we could build upon. And you can see their logo in the right next to the Kuma logo. Developer experience at American Airlines loves open source technology. Within our technology and transformation space, we look to the open source marketplace to help our engineering standards. American Airlines wants to be part of thriving open source communities. We spent quite a bit of time evaluating service mesh technologies and discussing with technical leaders. We saw Kuma open source stand out from the pack by offering batteries included. We have teams with use cases for traffic policies where certain workloads need to be isolated, the ability for multiple meshes with explicit requirements for traffic rules for sensitive data. The Kuma gateway will allow us to ensure API security on our applications, and Kuma offers cross-region and cross-provider support as well. Developer experience at American Airlines and Kuma seem to share similar goals. We want to make things easy with minimal upfront configurations. This is a high-level overview of what our infrastructure looks like. It's simplified, of course. We start with our security delivery content providers and our global traffic managers. We have a Kubernetes provider with multiple clusters in multiple regions, and we have Kuma installed on all of our clusters with a Kuma global control plane. We deploy Kuma using GitHub Actions. GitHub Actions allows us an easy way to deploy Kuma on both global clusters and our remote zones. We also use the GitHub issues and pull request comments to document our cluster's life cycles. We're looking to make the developer experience at American Airlines a delightful experience. To add on to cluster creation and bootstrapping, we have also simplified our global traffic management strategy. In the past, internet-facing applications had a lot of hurdles to jump through. We've simplified the process while keeping proper security in place. Anytime a new ingress is found on our clusters, our GTM provider is notified about the changes. As apps change clusters, our global traffic manager solution tracks apps from cluster to cluster, and as apps are removed, the GTM property is removed or IPs are adjusted. Using Kuma Service Mesh, we can place services anywhere within the mesh and ensure it just works with very minimal configuration. You can see our GTM sync service application being reached out to by our custom operator for GTM CRUD. And that GTM sync service can exist on any cluster, does not have to exist side by side with our operator. We've used Runway as a base to encourage intersource at American Airlines. The platform has made it easy, even for non-developers at American Airlines, to get started, to contribute, and to build their team's service requests into the platform. Our API management team built in management capabilities for APIs right within Runway. Our data engineering groups have built in powerful workflows to allow teams access to data lake items. Our InterSource team has joined forces to create a marketplace right inside Runway that encourages the reuse of components. Our file management team has built in ways to view information on our file transfer jobs, and they're continuing to push forward with job creation. Our Compute as a Service group has built in ways to create and view information on virtual machines. Those are just some of the highlights on our InterSource contributions. A large portion of what we've tried to achieve is around our Create app. This is how applications join our clusters and our mesh in a friendly way. We wanted to make it easy for the application developers at American Airlines to launch their apps into our Kubernetes environment and not to worry about the underlying infrastructure. Click and deploy. We have options for new app creation as well as deploying existing apps into our mesh. And we have big plans on extending these blueprints. We have a lot of abstraction layers that help us out in developer experience. Runway that I just showed helps our app teams onboard easily to our clusters and to our mesh, and it gives us a user interface to provide our abstractions on. The Runway Kubernetes operator takes in a small subset of YAML to expand and create Kubernetes resources. We shot for describe your app in 10 lines of YAML or less, and we made it pretty close. This operator is also awesome because we can change how app teams are deploying apps without teams actually having to be fully aware. When we needed to add Kuma locality aware routing labels, we updated the operator and all apps deployed in our ecosystem were gracefully updated. We also automatically update our global traffic managers based on ingress changes. So teams no longer have to manually fill out requests for GTM services or for security services provided by our delivery partners. With Argo CD, for our deployments, teams don't have to know much about deploying an app to Kubernetes. They simply update a YAML file in a repo, and the deployment is updated everywhere. It also makes rollbacks really easy as well. Our cluster service allows teams to securely create namespaces and projects through our Rancher platform. It also applies Kuma annotations needed at the namespace level. Our GitHub repos allow us to control the code and use GitHub actions using workflow dispatch to deploy our infrastructure. And we also document our traffic policies as infrastructure as code in GitHub repos. Our GitHub internal actions allow us to reduce duplication of code chunks, and Rancher gives us a way to abstract out our user management abilities within our clusters. We have a demo coming up. This will go through the whole Create app lifecycle within Runway. And once this video kicks off, we'll see logging into the Runway platform along with the Runway homepage. We have an option to create an app right in the sidebar. And once we authenticate with GitHub, it'll take just a moment, we'll see certified blueprints show up with a gold star. Those are blueprints that have been approved by our group. We also have community blueprints as well with a toggle on top of the last screen. Once a team fills in their short name, their application short name, a description, and some other items, we'll go ahead and select the cluster. This screen is pretty important because when a team selects their short name, we're automatically applying tags, labels, and annotations in the background based on that selection. We'll go ahead, trigger our first release, and create an AKS public ingress. We're selecting our cluster namespace. This namespace option is now auto-populating in our latest version. We'll review our deployment details and then click forward to generate our application. We used a little bit of cooking show magic to speed things up, but we're going to open up a new tab with our GitHub repo and our catalog entry. Looking at GitHub, we can go ahead and clone the code locally, make those updates, push the updates back up to GitHub. We'll also check out that our initial Docker image build is being created. This is going to be pushed up to our private registry using one of those internalized GitHub actions. Jumping in to the Runway catalog right now, we can see basic information. This page was loaded before the app fully had time to deploy and before the image got produced. So when we refresh the page, we saw a little bit more information and we see a URL. That URL, when clicking, you'll see the basic app that says change me. So that was a pretty quick demo, but let's kind of go over everything that was created during that demo. While we did do a little bit of cooking show magic to speed things up, for a full deployment, it took only 6 minutes overall. That included Docker image build time, security scanning, Kuma resources being created, the global traffic management property being created out in our traffic manager. Argo CD deployed the app, which is what you can see here. This is an Argo CD image. If we jump into the diagram, we'll see that we have a custom defined kind of web app. That web app has been expanded into normal K8 services, external services, deployment, horizontal pod autoscaler, and ingress. If we had secrets or config maps defined, you'd see those as well. From the previous screen, we all saw the Kubernetes resources that got created from the Runway platform using the Runway operator. All of those resources were produced from the above YAML, just 10 lines of YAML. That's very minimal compared to what it normally takes. And on the next screen, we'll see what it's been reduced from. I pulled a random app that got deployed through Runway recently. You'll see information on this screen about that app. They added some environment variables, some secrets, and some auto scaling settings to their lines of YAML. So they went a little bit bigger than the 10. They went to about 45 lines of YAML with all their environment variables and all their other custom settings. However, the app is the exact same thing we just built in the demo. It's a Python fast API app. The team spent a little bit more time working on it and iterating through it, but it also just took 6 minutes to deploy, to build, and have their updated image running. We went from 45 lines of YAML in the example I found to over 1,400 lines of YAML. We're really trying to ensure our teams don't have to be presented with tons of infrastructure complexity, but we'll allow that complexity when necessary. We've been partnering with a few app teams to run through our full workflow to deploy production apps to our infrastructure. One team in particular we've partnered with has a pretty cool new app coming out to enhance a customer's onboarding experience. The team, who typically deploys many microservices, has seen a reduction in a new app deployment time from days to hours. Outside teams that have less infrastructure typically ready can see a reduction in time from months to hours. Yes, I did say months. So the team has also seen an increase in app portability and less of a reliance on our cloud partners. That's a huge plus when we're trying to support the world's largest airline and utilize multiple cloud providers for our applications. Typically, teams in our organization need to be Kubernetes experts to launch apps to clusters, but not this team. Due to the amazing efforts by our contributing members of developer experience, the team mastered containerization to continue with the new infrastructure, and that's it. They really don't need to know much about Kubernetes. We also gave teams a detailed view into the service mesh using the Kuma tracing integration. Our customers can trace traffic from the cluster ingresses through the mesh to the app. This gives teams a much deeper insight into what's going on throughout the entire lifespan of a transaction without any blind spots. Another batteries included item from Kuma, and Kuma made it easy. Throughout all of this, we've been able to create abstractions to gain benefits without users being overwhelmed with yet another technology layer. Our blueprints provide a great starting point for teams with batteries included. The operator provides the ability to hook up apps into clusters and into the service mesh without ever realizing, as well as reducing the number of YAML, lines of YAML required to launch an app into Kubernetes. Our GitHub Actions automation provides the ability for our team to automate Kuma policies and infrastructure creation. The global traffic management service we built makes it easy to update ingress pointers to access our apps within our mesh. The Kubernetes infrastructure makes it easy for apps that are portable between our cloud providers, and Kuma makes it super easy to control traffic permissions, routing, and gateways. Kuma is easy to set up and easy to jump in with a service mesh. It's easy to span multiple regions, service providers without manual steps. Kuma makes it easy to communicate with services wherever they reside. And with Kuma, we didn't need to seek outside components. We simply used Kuma. As we look towards the future, we'd like to include more information about the Kuma service mesh, Kuma policies, and global traffic management information to our customers right through Runway so that teams can easily find the information they're looking for. We'd like to find ways as well to contribute back to open source with some of these efforts, maybe through a backstage plugin. We're looking at multiple meshes for different purposes, and we're looking to continue to enhance the developer experience by looking for modern open source technologies like Kuma Service Mesh to explore more capabilities of Kuma using policies.